is gravimetric analysis? A quantitative analytical method called gravimetric analysis is a method used to calculate how much of a certain material is present by weighing a sample. The foundation is based on the principle that the mass of a substance is directly proportional to its quantity. There are two types of gravimetric analysis, which is volatilization gravimetry and precipitation gravimetry. What is volatilization gravimetry? Volatilization gravimetry is by heating the sample or breaking it down chemically for the components in the combination to be separated. Any volatiles in the mixture are released by heating or chemical breakdown, changing the sample mass, which were then measured. On the other hand, precipitation method separates and precipitates the chemical to be analyzed as a solid compound. There is a phase shift in this instance. By using filtration, the precipitation is isolated from the liquid phase. The mass of the precipitate can be used to calculate the concentrations or the quantity of ionic chemicals in the solution. Gravimetric analysis can be used to determine the amount of wide range of substance. For instance, gravimetric analysis is commonly used to determine the purity of the substance. The purity of the material can be determined by taking its mass and comparing it to theoretical mass. This is crucial for sectors like pharmaceuticals. Another use for gravimetric analysis is to determine the amount of material in a sample, such as nitrogen in soil or chlorine in water. This is crucial for sectors like environmental monitoring. In addition, gravimetric analysis is also utilized for determining the compositions of a combination. The composition of a mixture can be determined by separating and measuring the mass of each component. This is helpful for the food and beverage sectors. In summary, gravimetric analysis is a method that measures the weight of a sample to determine the amount of material present. The approach requires a high level of ability and precise to guarantee precise outcomes. Hence, why it is beneficial for analytical chemistry.
So now, me and Lisa Maisara will talk about the theory of gravimetric analysis in food analysis. So basically, gravimetric analysis is a quantitative method and in analytical chemistry used to determine the amount of an analyte based on its mass. This method involves converting the analyte into a stable pure form that can be isolated and weighed. In food analysis, gravimetric methods are widely used for the determination of total fat contents. The process typically involves extracting lipid from food samples and then measuring the mass of the extracted lipid. One of the standard methods for lipid extraction in food analysis is bleed and dye method, which uses a chloroform or methanol solvent system. This method is known for its efficiency in extracting lipids from variety of food matrices. Other method used is AOAC method 983.23. It is a modification of the bleed and dye method. The proposed modification to AOAC 983.23 aims to reduce labor intensity and increase sample throughput, such as batch analysis, accuracy and precision, recovery rates, quality control. The modified method was validated through analysis of total diet standard reference material SRM 1548, which is routine assays of over 600 foods composite for clinical feedings trial and repeated assay of a quality control composite over 2 years. Gravimetric analysis remains a fundamental technique in food analysis, providing essential data for ensuring the quality and safety of food product.
Hi, my name is Alia Maisara binti Mustafa Kamal, and now let's move on to the methodology. The first step is food composite. Each of the food composite consisted of combination of few food such as fruit, fruit juice, vegetable, bread, cereals, and more. And each of the proportion represent a range of total diet consumption pattern. The composite was prepared in such way to inject the homogeneous mixture, and the temperature of the mixture was maintained below 25 degrees throughout the process. The sample was stored tightly in sealed jars and be cooled in -60 Celsius. And the frozen sample will then be brought in room temperature for complete mixing to obtain a uniform representative subsample. The second method is chemical and standard. A sample of 0.5 m sodium acetate was used in distilled deionized water. Dimethyl trichlorosilane, 5% in hexane, was used for siliconization process. Coconut oil was also used as fat, which contained cholesterol, retinoic acetate, menhaden fish oil, and more. Next is the moisture determination step. Moisture in each determination is prior to total lipid extraction using moisture solid analyzer. The amount of 2 until 2.5 gram of each of the food composite was used to determine the moisture by using the moisture solid analyzer in the microwave. The moisture will be vacuum drying for about 24 hours. Then the amount of sodium acetate needed for the extraction purpose will be calculated. The next step is total lipid extraction by proposed method. During this method, 5 gram of thoroughly mixed food composite was weighed into 500 ml polypropylene centrifuge bottle. Then 0.5 m of sodium acetate was added to make the total volume of the sample become 32 ml. 80 ml methanol and 40 ml of chloroform were precisely measured and added to the sample. Then, after it done, the sample was added to the centrifuge bottle and kept it. The centrifuge bottle will then be shaken for 30 minutes and 300 rpm.
The next method is the gravimetric determination of total lipid in extract by proposed method. The centrifuge tube with labeled sample numbers are placed in a metal test tube rack. Then it will be heated in drying oven for 30 minutes. The test tube will be cooled in a desiccator and weighed on microballads. The aliquot will be then pipetted accurately from the chloroform plate. All the instruments for operation of pipette were calibrated first before use. A polypropylene tube plug also were used to prevent the entry of food sediment or aqueous methanol. The last method is the total lipid extraction. During this method, all the food composites were already extracted. 5 gram of the food composite will be weighed and 0.5 molar acetate will be added. The tube will be shaken gently and incubated in water bed. Then, it will be transferred to semi-micro stainless steel blending after mix. The extract will be transferred again into a siliconized polypropylene bottle. The extract also will be equilibrated for 15 minutes before dispersed. So, all the statistical analyses are accomplished. Now, we move to the advantages of gravimetric analysis where there is no calibration needed unlike volumetric analysis. Next, the method will produce more accurate results because it will use an analytical balance to weigh the mass obtained and not based on the judgment like volumetric analysis. Also, we can use this method as a filtrate to examine any presence of contaminant that can cause inaccuracy. Thus, it will increase the accurateness. Now, we look to the disadvantages. Gravimetric analysis needs a long time to complete, so it is very time-consuming. Not only that, this method requires a lot of precaution steps. If we mess up one of the steps, it will spoil the analysis process. Last but not least, gravimetric analysis is restricted to a single element only, where we cannot analyze more than one element in a time. To conclude, gravimetric analysis is a quantitative method that is crucial in food analysis to identify the specific amount of the ingredients in food. By using this technique, the total amount of fat in coconut oil can be determined its composition by weighing the mass that have been gained during the process. This method is suitable for food analysis because of its high precision and less messy compared to the other method. Gravimetric analysis also can be used to determine the purity of the sample or to identify any contaminant that might be present in the sample.